To continue our discussions, as a recap of mucopolysaccharides. So, mucopolysaccharides, these are glycoaminoglycans or the GAG. So mostly they contain uronic acid and amino acids, amino sugars and acetylated amino sugars, meaning they undergone acetylation, the addition of acetyl group, plus the transamination process or addition of amino group. Okay, COOH or carboxylic acid functional group attract water molecules to produce viscous solutions. Usually mucin, viscous usually are mucopolysaccharides, mga slippery ni sila, no, mga ara sa lanat-lanat mula sa mga bones. Try to eat yung mga karne, usually sa part ng mga cartilages, so there is a slippery or viscous fluid there that is known to be the mucopolysaccharides. So we have another kind is hyaluronic acid, so mucopolysaccharides that is found in connective tissues, tendons, synovial fluid, and vitreous humor. Serve as lubricant in joints. Usually this is used in the treatment of arthritis. Sa arthritis, there is what we call small amount already of synovial fluid, okay? And one component synovial fluid, nandoon yung hyaluronic acid. So Hyalgan is the name of a drug that is used for the treatment of arthritis, okay? So these are the example of the mucopolysaccharides. Also we have the chondroitin sulfate, keratan sulfate, heparin, dermatan, hyaluronate or hyaluronic acid. Okay. So heparin, anticoagulant, widely used taking blood in vitro and clinical trials. When saying in vitro, it does not involve living organisms or tissues, and present in liver, lung, spleen, and monocytes, okay, especially in animals. Okay. Chondroitin sulfate, ground substance of connective tissues, usually distributed in cartilages, bones, tendons, cornea, and even the skin. Okay, yung mga chondroitin sulfate. Keratan sulfate, it is a GAG or glycoaminoglycans which do not contain uronic acid but found only in cornea and tendons. Ito yung mga keratan sulfate. So, major components of heteropolysaccharides, usually ito yung contain ng N-acetylmuramic acid and N-acetyl glucosamine, what is found in the cell wall of the bacterial cells. Okay, so cell wall of the bacterial cells also protects the entire prokaryotic or the entire cell structure. Okay, for pharmaceutical importance, so microcrystalline cellulose, this one is used as binder or diluent or inactive ingredients. They belong to inactive agents in oral tablets and capsule formulations. Okay, mga maka-binder diluent, they add to the bulkiness of the pharmaceutical preparation, especially tablets. Okay, preservatives sila. Okay, lubricants. Okay, liquid glucose is used in the base of oral solution and syrups. So stabilizer, ha. So in tablet, it is used as granulating or coating agent in tablet manufacture. So may coating agent yan, or sweetener in chewable tablets, or sucrose syrup is also used to mask the bitter aftertaste of a drug. Okay, kasi yung mga drug usually pait. So to mask the bitter aftertaste of the drug, you have to add sucrose. Okay, in liquid preparation, sorbitol is used as vehicle or solvent, sugar-free formulation as stabilizer. Kasi kung there are a lot high amount of sugar, usually stabilize yun. It is a preservative already. Vitamins and antacid suspensions also. Next, so approved carbohydrate drug, we have carbohydrate drugs. So example, generic name Glucobay acarbose, used in treatment of diabetes. Amdis for ophthalmic surgery. Sunamivir, so this one is Relenza for influenza virus. Tamiflu, oseltamivir. Topiramate, Topamax for the treatment of epilepsy. Yung Buglibose basin for diabetes. We have enoxaparin, Lovenox, cardiovascular disease. Digoxin, Lanoxin, this is a cardiac glycosides or cardiovascular disease. Okay, or cardiac stimulant drug. Erythromycin, Elluson, antibiotic. Okay, sodium hyaluronate, Hyalgan, osteoarthritis, Miglitol, Migtor-50, diabetes. Doxorubicin and heparin are anti-cancer in doxorubicin, rubicin, you know? So RUVI to correct. Heparin is anticoagulant. Okay. So another one. So this one are uses. So mostly it contains lot of carbohydrate content. Usually this is stabilizer at the same time gamit sa as coating No, gamit din siya as preservative. Okay? That's why when when you take acetaminophen, example 10 plus syrup, ito saccharin, 10 milligram per ml. So kung 60 ml yan, mga 600 milligram, so that is considered to be a strong, there is a large amount of carbohydrate. Okay, so matamis katama yung drug dyan to mask the taste of the acetaminophen also. Okay, so major metabolic pathway of carbohydrates. We go now to major metabolic pathways of carbohydrates. So diet, carbohydrates, starch, glycogen, disaccharides, example sucrose and lactose. Digestion or metabolism starts in the mouth because of the enzyme salivary alpha amylase. So this is rate limiting kasi when you chew the food, it's not na mag-chew ka ng food dugay-dugay, di ba? Rate limiting step only for the first step of digestion in the mouth, usually oral, because of the presence of amylase enzyme. When you chew the food, so usually digest na siya. Then we have the stomach. For pancreatic, alpha amylase will hydrolyze 1,4 linkage of smaller subunits of maltose, isomaltose, dextrins, of course, to monosaccharides. So, kung ma-breakdown ito sa monosaccharides, no? Example, ang maltose mo, example, alpha amylase will hydrolyze linkage to smaller subunits like maltose. So, next to this one, yung mga maltose, isomaltose are disaccharides. It will be metabolized to a monosaccharide. So, absorption takes place in the brush border of the small intestine containing enzymes. So, may mga sucrase that will hydrolyze sucrose into fructose and glucose. Lactase for conversion of your lactose to glucose plus lactose. Maltase plus mannose plus mannose, and isomaltase, mannose plus mannose also. Okay? Then hydrolysis of disaccharides into the monosaccharides which then absorb. So before the absorption process, all polysaccharides will be converted to disaccharides. Okay? And then in a small intestine, before they absorb, they will be converted to monosaccharides, because absorption is based on the size and then the molecular weight of the biomolecules, diba? It depends upon the size. So if the smaller the size, or the smaller also the molecular weight, so it's easy for the absorption process. So that is the purpose wherein polysaccharides are converted into monosaccharides. Okay. So absorption of carbohydrates. Take note, enzymes on the luminal surface of the small intestine epithelial cells digest disaccharides into the monosaccharides. So if this is your small intestine, so there is what we call enzymes that is present, diba? Sucrase for sucrose that will be converted to fructose plus glucose, correct? So monosaccharides are absorbed in the cell's facilitated diffusion process and or by secondary active transport with sodium dependent. Okay, usually ito na yon, digestion, maltose to glucose plus glucose, for example. So we have here the small intestine, we have the apical membrane. Okay, there is enzymes present here. So this one, so maltose siya, so glucose plus glucose before it will cross the cell membrane. So it is, example, the absorption of fructose, di ba? Kung coming from sucrose siya, that is sucrase, that will be converted to fructose plus glucose. So fructose crosses via facilitated diffusion or via a protein carrier. Then it will cross the cell membrane and then it will exit up to the capillary or bloodstream via facilitated diffusion Japan. While glucose is sodium dependent, so the secondary active transport, wherein there is a utilization of energy in the form of ATP, and then glucose enters the cytoplasm. Then the absorbed monosaccharides leave the epithelial cells by facilitated diffusion siya. So meaning there is no energy involved. Then it will enter the bloodstream and distributed throughout the body. Okay? So same with galactose, sodium dependent. Then this is secondary active transport, then crosses the cell membrane, the cytoplasm, and then it goes through the bloodstream, distributed throughout the body. Okay? So this is the absorption process of carbohydrates. So usually the port of entry, class, take note, is in the small intestine. So after they are digested in the stomach, then after that one they will go to the what we call this one, to the small intestine for absorption process. But before they enter, yung mga disaccharides will be converted to monosaccharides, because absorption, take note, is based on the weight and size of the biomolecules that are being absorbed. Next, for co-transport from the lumen to intestinal. Okay, so we have here the hydrogen ion, okay, and sodium glucose transporter. So after the glucose are after the disaccharides are being hydrolyzed, so we have here the glucose, for example, or even the sucrose, diba? Before sucrose mag-cross siya, usually it needs a transporter. Okay, so this sucrose will be converted to glucose. So this is considered to be a active transport, wherein it pumps hydrogen atom with the aid of ATP, and then hydrogen ion also combined with the sucrose co-transporter, and then or the sodium glucose transporter 1. Okay, and then it will enter the cytoplasm. Okay, so uniport system release glucose, this one in the microvilli, this is the cells found in the, or epithelial cells found in the small intestine. So mga uniport, it is only one, the transport mechanism or the transport process is in one direction only. So we have two sodium, for example, and the glucose. So sodium glucose symport system is driven by high extracellular sodium. So glucose plus two atoms of, or two ions of sodium, it will enter via the symport system or the carrier. Then inside, they will split. Then sodium will enter the bloodstream, exchanged with potassium, that is considered to be active transport, while glucose will enter via glucose uniporter glucose transporter to downhill efflux. Mga baka down efflux, that is exit. But ang opposite ng efflux class, that is influx system. May influx pasulod. So efflux system niya, that is aided by a protein or uniporter or transporter from the cytoplasm up to the bloodstream. So this is the uniport system release of glucose. So uniport, one direction only. Okay, so glucose transporter 4, when glucose are inside the body, it will enter now the muscle tissues through glucose transporter 4. It needs an insulin class. Insulin is very important. It is the hormone involved in the transport of glucose with the help of glucose transporter 4 from outside environment of cell down to the tissues for glycolysis process. Okay, so the mechanism, okay, insulin binding to its receptor usually binds with the beta subunits on the tyrosine amino acids. Take note, this is insulin binds to the beta subunits or the beta receptor. Then the binding of that insulin to the receptor leads to the autophosphorylation process or activation of phosphorylation process. Autophosphorylation, that is automatic. Okay, next, after the autophosphorylation process, the autophosphorylation process activates the insulin receptor IRS 1,2, and then the phosphatidyl inositol or PI3 kinase enzyme. So this is series of activations leading to cascades or series of events that ultimately leads to translocate the glucose transporter pool that is found in the cytoplasm. Then it will go up to the cell membrane to transport the glucose. Okay, so the transport of glucose from outside to inside environment or to the tissues is aided by glucose transporter 4. So before ang glucose transporter 4 activate, so kailangan it needs insulin. Okay, so that is considered to be the before it translocate ang glucose transporter 4, it needs an insulin. So insulin is very important. That is why if you have the diabetes mellitus, So there's a problem already in production of insulin. So walang glucose na to enter the muscles because glucose is the source of energy. So there's a problem already here. Okay, that's why class in pharmacology, remember, if insulin is given with beta adrenergic blockers or beta blockers or antihypertensive agent, okay, there will be interactions because beta blockers will block the beta receptors and then insulin cannot bind with this one. So when you give insulin, then there is a beta receptor, so that is already the drug interactions. So that is very important in biochemistry. At least you remember na bawal pala yung insulin at the same time magbigay ka ng mga beta blockers kasi ang insulin binds with beta subunits in the treatment of diabetes. Gusto ko na nga talaga ng beta blockers, hindi na makabind si insulin dito. So there is no glucose. Okay? There is no what we call a transport of glucose. Okay? So problema yan. Okay? Next. So glycolysis. So we will discuss this one. The Meyer-Hof or pathway, an anaerobic enzymatic conversions of glucose to simpler compounds, lactate or pyruvate. So resulting in the energy stored in the form of ATP as occur in the muscle. So derived from Greek word glykis, sweet, or lysis meaning split. So glycolysis is Meyer-Hof pathway. Okay? So we have 10 steps and we go one by this one.